In this lesson, you will learn about IPsec. In this lesson, you will learn how to do the following. Configure IPsec using the FortiManager VPN Manager. Troubleshoot the most common IPsec problems. Check whether IPsec encryption and decryption is offloaded to hardware. Use the debug flow to isolate IPsec traffic issues. Capture IPsec traffic and monitor the status of an IPsec VPN. In this section, you will review some IPsec concepts from the NSE4 course. IPsec is a suite of protocols for authenticating and encrypting traffic between two peers. The two most used protocols in the suite are Internet Key Exchange, IKE, which does the handshake, tunnel maintenance, and disconnection, and the Encapsulation Security Payload, ESP, which ensures data integrity and encryption. IKE negotiates the private keys, authentications, and encryption that FortiGate uses to create an IPsec tunnel. Security associations, SAs, provide the basis for building security functions into IPsec. There are two distinct phases that IKE uses. Phase 1 uses a single bidirectional SA, and Phase 2 uses two IPsec SAs, one for each traffic direction. Next, you will review the differences between aggressive mode and main mode. This slide shows main mode, where 6 packets are exchanged. The client initiates by proposing the security policies. The responder selects which security policy it will agree to use and replies. The initiator sends its Diffie-Hellman public value. The responder replies with its own Diffie-Hellman public value. The initiator sends its peer ID and hash payload, and the responder replies with its peer ID and hash payload. In comparison, this slide shows the aggressive mode negotiation, in which only 3 packets are exchanged. The client initiates by suggesting the security policies and providing its Diffie-Hellman public value and peer ID. The responder replies with the same information plus a hash, and the initiator sends its hash payload. In this section, you will learn how to configure IPsec VPNs using the FortiManager VPN Manager. On the VPN Manager screen, you can configure IPsec VPN settings that you can install on multiple devices. The settings are stored as objects in the Objects database. You push the IPsec VPN settings to one or more devices by installing a policy package. Follow these steps to configure VPNs with the VPN Manager. Create a VPN community. Add gateways or members to the community. Install the VPN community and gateways configuration. Add the firewall policies and install the firewall policies. To create the VPN community, click VPN Manager, IPsec VPN, VPN Communities, and then click Create New. Depending on the VPN topology to install, there are 3 types of communities: full meshed, star, and dial-up. The VPN community contains the IPsec Phase 1 and Phase 2 settings that are common to all gateways. The next step is to add gateways to the community. There are 2 types of gateways. Managed gateways are FortiGate devices managed by FortiManager, and external gateways are FortiGate devices not managed by FortiManager, such as devices made by other vendors. In VPN gateways, you configure the node type, hub, spoke, and so on, depending on the VPN topology you select. For example, hub and spoke options are only available in star and dial-up topologies. For each gateway, you can also configure the protected subnet, interfaces, and some advanced settings. When you configure VPNs using the VPN Manager, you cannot create the firewall policies for IPsec using FortiManager until the IPsec community and gateways configuration are pushed to the devices first. Otherwise, the IPsec interfaces will not have been created yet. The VPN Manager always creates interface-based VPNs. After you push the IPsec configuration, FortiGate and FortiManager display the IPsec interfaces that you need to create the firewall policies. In this lesson, you will learn the basics of IPsec troubleshooting. When isolating IPsec problems, it is useful to understand that an IPsec connection can be described as a four-step process. 1. Interesting traffic triggers the VPN negotiation. Traffic is called interesting when it must travel through an IPsec tunnel. In other words, encrypted and encapsulated to reach a remote network. 2. Phase 1 opens. 3. One or more Phase 2s open. 2 IPsec security associations are negotiated for each Phase 2. And 4. Traffic crosses the tunnel. So if you have an IPsec issue, you should determine in which of these 4 steps the problem has occurred. The command diagnose VPN tunnel list displays the current IPsec SA information for all active tunnels. The command diagnose VPN tunnel list name, where the name is the tunnel name, provides SA information about a specific tunnel. The command get VPN IPsec tunnel details provides detailed information for the active IPsec tunnels. The command diagnose VPN IKE gateway list also provides some details about a tunnel, and the command diagnose VPN IKE gateway clear closes a Phase 1. The command get VPN IPsec stats tunnel provides some global overall counters related to all the VPNs currently active. The other 2 commands shown on the slide provide summarized information about the VPNs. The IKE daemon handles all IPsec connections on FortiGate. It's important to familiarize yourself with the available filter options. You use these options to filter the output of the IKE real-time debug so that only information relevant to you is displayed. The most common filter option is DST-ADDR4, which you use to filter the output by the IP address of the remote peer. Filtering by name is helpful when the remote peer IP address is unknown. After setting the filter, enable the IKE real-time debug using the following commands: diagnose, debug, application, IKE, followed by the bit mask value, and diagnose, debug, enable. The table shown on this slide includes the type of output that is enabled by each bit in the bit mask. The most common values for the bit mask are 255, all outputs enabled, and 63, shorter output. They both show the DPD packets and all the information required for troubleshooting IPsec negotiation problems. Let's look at the output of the IKE real-time debug during a main mode negotiation. As explained earlier, main mode requires the interchange of 6 packets. The real-time debug shows when the first packet, first main mode message, arrives. Then the debug shows the negotiated settings for phase 1. A message is generated once FortiGate identifies the VPN configuration to use, with the name of the VPN. Next, the output shows the remote peer's information. The second and third main mode messages arrive. After the authentication is successful and the pre-shared key matches, a final message is generated to indicate that phase 1 is up. This slide shows the output of the real-time debug for phase 1 aggressive mode. It displays the 3 aggressive mode packets interchanged and the proposals. This slide shows the phase 2 negotiation. The debug shows the phase 2 proposal from the local gateway and the phase 2 proposal coming to the remote gateway. In this case, both proposals, local and remote, match. Next, the output shows the negotiated phase 2 settings. The last messages confirm that the phase 2 is up. If the VPN is up, but the traffic cannot cross the tunnel, you should use the debug flow. This slide shows an example output of the debug flow for traffic that is crossing an IPsec tunnel. The output shows the following: packet arriving, packet being allowed by a firewall policy, packet entering the tunnel, packets being encrypted and sent. If the traffic is not crossing the tunnel because of a routing misconfiguration, the output of the debug flow shows it. The debug flow also displays if the traffic drops and why. For example, when packets don't match the quick mode selector. If you need to capture the IPsec traffic, remember that the IP protocol and UDP port numbers depend on NAT-T and the use of NAT. If there is no FortiGate located in the middle that is running NAT, IKE traffic uses UDP port 500, and ESP traffic uses IP protocol 50. This slide shows the 2 sniffer filters that the sniffer command must use to capture each of those traffic protocols. If NAT-T is enabled, and there is a FortiGate located in the middle that is running NAT, the sniffer command must use a different filter. In this case, IKE traffic uses port UDP 500, but switches to UDP port 4500 during the tunnel negotiation. Additionally, ESP traffic is encapsulated inside the UDP 4500 channel. On some FortiGate models, you can offload the encryption and decryption of IPsec traffic to hardware. The supported algorithms depend on the model and type of processor on the unit that is offloading the encryption and decryption. By default, hardware offloading is enabled for the supported algorithms. This slide shows the commands you can use to disable hardware offloading manually, if necessary. All IPsec SAs have an NPU flag field indicating offloading status. In the case of IPsec traffic, the FortiGate session table also includes that field. First, when Phase 2 opens, the IPsec SAs are created and loaded to the kernel. As long as there is no traffic crossing the tunnel, the SAs are not copied to the NPU, and the NPU flag shows 00. The value of that field also remains 00 when IPsec offloading is disabled. Second, if the first IPsec packet that arrives is an outbound packet that can be offloaded, the outbound SA is copied to the NPU and the NPU flag changes to 01. However, if the first IPsec packet is inbound and can be offloaded, the inbound SA is copied to the NPU and the NPU flag changes to 02. After both SAs are copied to the NPU flag changes to 03. In FortiOS 5.2.8 and 5.4.1 and later, you can enter the value 20 in the NPU flag field. This value indicates that hardware offloading is unavailable because of an unsupported cipher or HMAC algorithm. This slide shows a summary of the most common IPsec problems and solutions. If the tunnel doesn't open, use the IKE real-time debug. In such cases, an error message usually appears. When the tunnel is bouncing, you usually see that DPD packets are being lost, which indicates that the problem might be on the ISP side. If the tunnel is open, but traffic isn't passing through, use the debug flow. One of the peers might be dropping packets or routing traffic incorrectly. Another possibility is that the packets don't match the quick mode selectors, so FortiManager drops the packets. In this lesson, you learned how to do the following: deploy IPsec using VPN Manager on FortiManager, troubleshoot IPsec, offload hardware for encryption and decryption, identify common IPsec problems, and capture IKE and IPsec traffic.